Today we're going to be kind of walking you all through lessons that we learned from automating an AI data center. So we'll kind of go through the process, but first we'll start with introductions. I'm Mikhail Yohman. I've been with OpsMill for just over a year now as a solutions architect and basically helping customers and community around different integrations or using Infrahub is kind of what we do on the daily.
Yeah, Alex
Alex?
Gittings, based in near London in the UK, and do the same as Mikhail. We started around the same time, a few weeks apart actually. So we've been here just over a year, and this was kind of one of the first big projects we worked on.
Yeah, so what we'll do is we'll give you a kind of a project overview, why the customer did choose Infrahub, some of the features we did use in implementing it. There were some key features, and then we're going to kind of dive into the deliverables of the project and kind of break those down for you and the different components we use to meet those deliverables. We'll then go through lessons learned. This is going to mainly be around building the automation. And then we'll finally dive into the product evolution based on the project. So we learned a lot through it. The product grew tremendously over this project. So we will finish on that note.
Perfect. So the project overview, um, the main thing was we had to deliver a large AI data center. We can't give specifics, but it was very large, based on an EVPN fabric on the front end and InfiniBand on the back end. Um, and this was like the starting point. It will get bigger in future with more data centers for this customer being deployed. The main issue around this project, I wouldn't say issue, but one of the main key parts of the project was the time frame. We had to go from design to deployment and have boxes running code and Infrahub all set up and running everything within 6 months. Um, and then finally, obviously, Infrahub was a big part of delivering this data center. So we went from designing schema, uh, designing generators to build the customer's intent, and then transforms artifacts and workflows. So yeah, big project. And we're going to talk about, Mikhail's going to touch on the kind of design of the data center.
Yeah, so this was a pretty large data center. It was mainly modeled. I guess we didn't do it, but this was kind of the design we were provided. And really, the point of this design is the scalability and really scaling the different building blocks. So you end up adding, spine planes, and that allows, pod growth and just extra scalability. So you could scale at the pod level or at the plane level, and that's to give you the whatever your subscription ratios are. We ended up with an OSPF and BGP underlay and a VXLAN and EVPN overlay. Um, the InfiniBand backend wasn't something that we did. That was developed actually by the customer in parallel with this. So they ended up doing a lot of the InfiniBand side. And then on top of that, the support, right? We obviously have to have an out of band network. So we developed that alongside this
Yeah,
as
it's quite funny
well.
actually. The out of band network was actually very large. It's like a considerable part of the data center, just managing and building the out of band network from the firewalls. And it again was a spine leaf layer 2 architecture across the data center, um, per pod with console servers, the lot. It was a very involved project. So why did the customer choose InfraHub at this point? The main thing is like you can see the complexity in the data center that's being built. Um, and modeling such a complex data center requires a lot of attributes and relationships that might be unique for their use cases and what they want to get out of the data center and the tooling. So one reason is the flexible schema, of course. They were able to create custom definitions of like location and design hierarchy from data center interconnect, pods, fabrics, all that kind of good stuff. Then we have the middle part, the kind of meat we'll talk about, which is like a design builder. We call them generators, but we'll essentially build the data center or all the objects that are in the data center based on some design input. And you'll see how we built this utilizing workflows as a key part of that design builder. And then the output, the other key area was the version controlled artifacts as well as the objects in Infrahub. So being able to create a branch, edit data, and see how that affected the configurations. But they even said to us like it's the ecosystem around Infrahub is why they chose Infrahub. The developer friendliness of the SDK is a core part of the product. So it allows engineers to build scripts easily and integrations with the wider ecosystem. And one key thing they said was that Infrahub's not just like a set of scripts that they used to have. It was like a key part of their platform in the wider ecosystem, and it's delivering the capabilities on a wider level. And also to kind of not toot our own horn, but the people in OpsMill are really good. Obviously, me and Mikhail worked on it, but everyone, the back end engineers, the front end team, they're all really great team, and that's why they wanted to work with us.
Yeah, so we'll start to get into some of the features we used. So, as Alex had mentioned, generators are a large portion of this. They basically allow you to define, inputs, which are typically schemas, so you could relate those to different objects within the database. It could have, different attributes as well to toggle specific design criteria. And then we take that schema or the output of that schema and the actual implementation or the object that's created from it is consumed by the generator, which is a Python script. And that basically encompasses all the business logic. So, based on their inputs, we need these outputs, and then it'll basically generate, everything underneath it. Um, with that, it ends up creating a lot of the objects. So in this case, it basically created the data center. And we'll kind of go into a little bit of how we broke those down, into different generators to accomplish our deliverables. Generators are idempotent and declarative. So if an input changes, we will take care of, removing objects that may not have been generated again within this run. So it'll actually kind of remove things. So that's the declarative approach they take. And it really helps to ensure like a consistent state with those underlying services. And generators are really flexible in what you can generate.
So another key part of the product we utilized here was the artifacts and transforms. You'll see from the deliverables of the project that this was a key part of ensuring the whole data center build went successfully. And what artifacts and transforms are the ability to pull data from Infrahub, manipulate it or transform it into a different type of output that is consumable for a different part of the business. In this case, it was things like cable plans and things like that you'll see. So artifacts are the result of a transformation. They can either be Python or Ginger 2.
Great. One of the other features we used quite a bit was resource managers. We use those to kind of a lot for IP addressing, so point to point links whenever we're building the underlay. We use that a bit, or quite a bit for that. We also used it for like VLAN assignments as well. So basically, we have a range of numbers for the VLAN IDs. So really, we're kind of hiding some of those details and saying, hey, just pick from the pool. We don't really care, you know, what it is, as long as it's within this defined range. It allows the tracking of ownership as well, and these are idempotent in nature. Uh, how they are idempotent is basically you use unique identifiers, and when it runs again, it'll build the identifier and then uh, use the existing IP address if it exists. Is there anything you wanted to add there, Alex? Okay.
So the key deliverables. So we had one of the main ones. The first one we had to deliver for the customer was a cabling plan. The the building, the physical building, the data center, and the first thing they'll do is start building structured cabling, and then they'll put devices in and start cabling up the different networks from the InfiniBand, the Ethernet, and the out-of-band network. So the engineers that are going to site to do all this layer one work need to know what they're plugging in and where. So a key part of Infrahub there was to one, generate that the connections between all the devices so that this team had the right information about what is connecting where and what's required. So you can start then planning orders of cables based on the output of Infrahub. So you can be quite specific. The second deliverable was obviously device configurations. We need to deploy the data center at the end of the day. So we need a full configuration rendered by Infrahub. And then the second was how do they manage this data center going forward? They don't want to be adding objects like VLANs or different point-to-point links and enabling VLANs on trunks manually. They want workflows, and we call these services. And we work with the customer to define these services. So some of them were like add new rack. Like when you're doing large data centers, like you talk in racks, you want to add capacity, you add racks, you add pods. In this instance, we build rack generators. We built VRF generators, VLAN generators, so that they can add services. So you specify a VLAN, it will pick it up out of the pool and enable that VLAN throughout the list. We'll go into more detail about that shortly.
Awesome. So, really, we had to take the design right. We have the reference design, but there's obviously all the different inputs we do have, and specifics to the customer themselves. So we ended up working with one of their architects. They were kind of in control of the design for this DC, and they were pretty much the primary architect here. So a lot of the documentation was in Confluence. So documenting, prefixes, VLANs, were a lot in Confluence. We also had some configs as examples of the implementation, which is some of the inputs we use to kind of create the models, right? Not to be vendor specific, but the configurations kind of helped us understand how it was implemented. And then they also had their physical design in Excel. So that was kind of the physical layout, the pods, racks, and all that. So we use that to help us understand how they built the data center. And a lot of it is, rack based, which is pretty typical with these because they want to be able to just plug things in, typically in larger data centers, and not have to fully design it. So it's more composable. From the rack level. Um, some of the challenges with some of this is just the data was kind of everywhere, so we had to kind of decipher it and then figure out how to get it into Infrahub. So some of that we did use YAML as well to import objects into it and kind of define the different building blocks that we'll talk in a second. Um, is there anything you wanted to add,
Yeah,
Alex?
it's good. We have set some questions in the chat right now. So Thomas,
Okay.
how did you generate cables? The generator handled all of this. Essentially, we used interface roles on the interfaces. We'll probably go into more detail, but we specify interface roles and map the interface roles that connect to each other and the patterns that they use to connect them for HA purposes. Um, did you use a cable schema from cable library? Yes, pretty much use that unchanged, Mitej. Um, all the deliverables were using generators, so they are run in Infrahub. They are not separate Python scripts. When you create a node in Infrahub, it automatically kicks off a task to generate things. That's the whole idea of generators. Sorry if we didn't cover that part. And yes, Mohammed, when we get to the templates, we'll show you some kind of templates, but they were meeting customer requirements and configuration.
Um, so really, once we were able to kind of decipher the design and understand it fully, right? We did have to build in customer requirements, but ultimately, when you want to start, we really started lean, right? So one of the foundations that people typically want to start with is the hierarchy. So how do you define the different building blocks and components? Um, but we kept it minimal. Our initial schemas were a site, a data hall. We had to ask more questions, right, to kind of understand what that meant. What could a data hall be? And ultimately, it is an Ethernet fabric, which is the front end, and then the InfiniBand as the back end, and then the different building blocks such as the pod and the planes that could be scaled out. So we went in and kind of figured that out with the customer and iterated away with it until it made sense. And then we were able to, capture that the design that we discussed with them into these models, and that basically provided us our foundation. As we kind of go through the different deliverables, we do want to keep in mind to keep everything as vendor agnostic as possible. So typically you'll have a more generic model, or not generic, it's still going to have attributes you need, less vendor specific, and those vendor specific things will typically be in templates, whether it's, the output of just the commands. But we modeled OSPF, in a generic way as an example. Another key thing, it's not really on the foundations, but we did use primary attributes, and we'll talk about those now. So these are pretty.
To just cover the design intent is asking things like questions during the discovery phase of like how many fabrics per hall, what are the rack types? If you have a rack type, how many leaves, how many spines does it have? How's it cabled? We're asking this of the customer to be able to build the intent in the generators and the business logic in the generators, but we need to capture the input somewhere, and that might be in a model and a schema somewhere. So, for example, a pod schema might have a relationship to however many rec types are needed for that pod to be created.
Awesome.
So,
Yeah, so
I was going to
go
say, so
ahead.
if anyone's ever seen like a talk from Damien from AutoCon or anything, or attended one of our workshops, we talk about these three primary attributes: role, which captures the primary function of an object; status captures all the stages of lifestyle, whether it's active, decommissioned, etc., and the kind. And this is kind of inherent with Infrahub because every node is a kind. So uh, we have that inherently in Infrahub. So we just needed to add role and status to things.
Yes, and a lot of these are used in like templates and stuff to kind of understand stuff, and we could dispatch, to different templates that may require, specific things.
Mhm.
And yeah, definitely show examples of that. So for our first deliverable, it ended up being the cable plan. So initially, we needed to provide this to the DC ops team so they could understand, a lot of it was around how many cables to order and all that, as well as whenever we actually get the equipment, where do they rack it? So that was the importance of this. And we basically ended up keeping it small, keeping it detailed. Our schema, we didn't try and solve everything day one, We also used the generator to implement it. I believe Alex touched on that a little bit earlier, as well as the cabling was all within a generator. And then our artifact was actually a CSV that they use. So that was part of the requirements, was what format did they want it in and what information they wanted within it.
Yeah, so to get this, we need so the problem is that the DC team needed to actionable cabling instructions, not just a network diagram. It's hard to kind of tick off a network diagram. They need spreadsheets and things like that. Doing the cabling for a data center this large is just very prone to errors if you're doing it manually, and it doesn't scale well when you start adding new uh, pods or new racks. It can be quite time consuming. And lack of traceability, we need to know where things go and how things were generated. So what we modeled what we needed to for this part of the project. So a site, a hall, a pod, a cabinet, to know where the device goes. We had some device context, so we had vendor models, manufacturers, the role of what we're connecting, whether it's a spine, a leaf, a super spine, for example, whether it's a firewall, an Uber access switch, etc. We have roles for all of that. We also then had interface attributes. We modeled interfaces. So the roles of those interfaces, whether uplinks, downlinks, etc. The SFP types that they were, that's quite important when you putting in an order to a vendor. You need to know how many SFPs you need. And uh, a way to connect interfaces together. So, for example, we had a model to link.
Yes, and this is where we start to get into those primary attributes. We didn't necessarily have those on those building blocks. Although the kind is built in really to Infrahub. Ultimately, it's basically a schema
Mhm.
node. Just as an example, this is somewhat of what it ended up looking like. So we use some of the concepts such as a generic that had basically the role of the interface on it, and as well as the status. And then we kind of separated it out a little bit more. So we also had a physical interface generic. And then this basically said, hey, this physical interface can have a link on it. We went a little bit further as well to having a L3 and L2 interface along with the breakout interface. And this kind of allowed us to model it a little bit more to what they were using. But those are the main features we use. The generic that had some of those shared attributes, and then we got more specific in our like
Yeah.
physical L3 and L2
So for anyone that
interfaces.
hasn't seen this before, concept of generics allows for the L3 interface to have specifics like it can be related to an IP address, and there's nothing L2 related on there. And on the layer two, you might have you might have what VLANs are trunked, you might have the native VLAN and things like that. So they don't intermix, and you start making the models very specific to that use case and make sure that your attributes are not optional, they're mandatory.
Um, awesome. So, do you want to speak about
Of
the
course, yeah.
generator?
So there's a lot of information here. So for someone who asked the question earlier, do we do the cabling in the generator? Of course we do. As much as we can in the generator, we want to apply the business logic. So we had some input from somewhere, um, from the customer. It was in the form of a YAML file that defined like what rack types were available to us to cable up, and the fabric structure, what sites were available, what halls, etc. And then we had different pod definitions. So one might be a GPU pod for the H200s, for example, or one might be a storage pod. And each of these pods had spine leaf counts. And that's important as input parameters because the generator can take that. And if you say this pod is a storage pod, it needs 8 spines, the generator will go and build 8 spines. If you say it has 16 leaves, it will create those 16 leaves. Um, Now, when we started this, some features in Infrahub didn't exist. So we built our own version of doing like what we call object templates now in Infrahub, but this didn't exist at the time. So we said, if we need to build a device of this model and manufacturer, it needed to have all these interfaces already on it of these specific roles. So we had a spine, a super spine, and it had a certain amount of downlinks or uplinks. This didn't exist when we started the project, and ended up being a feature request, and it's now a key part of uh, of Infrahub, and the range expansion and all that, which is really good. And out of that, you end up getting the complete physical topology. The input parameters get taken in, and the generator will apply the business logic about what it does with that input parameters, like creating all those spines, leaves, and cabling them up in a certain way. And at the output, we actually get all those objects in the database, the L1, L2, L3 interfaces, SFPs with part IDs, and the connections that connect them all. So you can kind of see uh, the flow at the bottom there, which is kind of good. And this is what, on the right-hand side, is what a generator might look like. This is taken from our bundle DC that anyone can go and look at. So if you've got any questions about cabling, etc., it's a good way to go and see kind of what we're achieving here. It's like the open source version.
Yes, and on top of that, we actually ended up having this as a Python library. So we made a lot of our code
Yeah,
reusable. So we would just call functions in our different generators that we'll go through. So due to it just being Python code, that's kind of what we ended up doing, was treating it more like a Python project and reusable components, just to due to the size of this project itself. After the generator was ran, right, we have all our objects, we have our devices, we have our interfaces, and we have our cables, with everything. And one thing that we learned early was building the artifact, um, as you start is always a good thing. We ended up being able to like kind of show the customer progress. And we were able to, is this correct? Is this not correct? And kind of solve some of the data issues. Did we not interpret the design appropriately and all that stuff? So that was a really big help throughout this whole um, project itself. We were also able to break down this artifact a little bit more. So, based on our building blocks, we were able to generate the cabling plans per pod. So instead of a one large CSV, they're able to actually just look at little compartments as they're deploying a pod. Um, and this ranged from everything. It wasn't just the fabric, right? We mentioned we have the OOB and the InfiniBand. That's what took care of all of that. So we were able to kind of compartmentalize for that, and it was a huge help on making sure that we caught anything that may have been incorrect earlier, rather than once the DC team actually got the equipment and started cabling and things didn't make sense.
yeah. Probably one thing to highlight from the previous slide and generators is, probably just take note on, we did the physical because the requirement was a cable plan. We did a generator to generate the physical. Um, we wouldn't, you'll see by the end, like maybe we wouldn't recommend that going forward. Obviously, you'll see our learnings, but um, you know, we've trial and errored this, and we have some improvements to make. But you'll see our lessons learned towards the end. But it's good to learn about our process, and what artifacts and the customer requirements at the time that led us down this path of the reason why we achieved it like this. Uh, Perfect. So the next one, we're on to the second deliverable, which is what most of us here probably want to see, right? We want to see config that can be deployed to a device. Um, uh, so again, we didn't have OSPF models at the time when we started this deliverable. We were focused on delivering a cable plan. because by the time the engineers have on site have started cabling, we should be deploying config, and that was like the time frames. It was we got the cable plan, they start cabling. By the time they're finished cabling, they're going to power these devices up, and the config should be ready. That's the kind of timelines we're working with here. So again, we were only looking at modeling what we needed to. We didn't model everything. So the key things we were looking at were kind of the routing protocols that were being used. So BGP, OSPF, different the VRFs and where they live, and these were strategically attached to different building blocks. So, for example, instead of assigning an ASN to a physical device, we could say, okay, for all the spines, you're going to take the ASNs from the pod layer, so we can inherit attributes or data within the templates. So that was
Sure.
the routing, the switching. Again, we modeled VLANs, layer two domains, the L2 interfaces. Because we were starting to build VLANs and VRFs, we started then adding those VLANs to where they needed to. So if we knew a VLAN needed to be at a certain part of the fabric, we could traverse the tree and say, hey, this VLAN needs to be on all these links in between these the spine and the leaf. And it would go, and the generator had the logic to be able to add that VLAN throughout the hierarchy of the interface tree. We then modeled overlay concepts, so VNIs, VTEPs, and all while doing this, we're using some inputs from the customer. So they might have said, for this pod, you need this to utilize this prefix. And we had resource managers to manage that prefix and allocate loopback IP addresses for VNIs, VTEP interfaces. We even used resource managers to allocate VLAN IDs and VNI numbers. It's really good stuff. And then obviously we had shared services, DNS, DHCP, logging, and all that good stuff that we needed to model because it was changing over time, and that's good. And why does kind of getting this point, why is it important? Is that it allowed us to then go and say, hey, give me all the BGP sessions for pod 3, and we have models for them. Which allows us to then derive configurations from that type of query or feed it into external systems, etc. And also, if you change a fabric ASN, we change it at one point. We don't need to change it on all the devices. We can change it at the pod level, and that will influence all the device config out of that. So getting the schema design right was quite important. And then, yeah,
Yeah, and to
questions.
build on top of that too is like whenever you put a device somewhere, right? If they put it in pod one or pod three, like Alex was saying, we just traverse up and then it gets kind of those attributes. They don't fully inherit it, but based on where you put the device is the data that it's going
Mhm.
to get. So that's really important to being able to just say, hey, the design's built into our models. I want this device here, and now we know how to get the data to build the configurations.
Yeah. There's some things we're missing out of here. Like, for example, we didn't model what didn't need to be done. For example, route maps. It wasn't very high on the customer's list to have route maps modeled. Obviously, they wanted them eventually, but these are static things that could be added to templates at the templating stage, such as prefix lists. They were handled at the templating because it wasn't important to model it at that point in time. It can be added afterwards. It's always better. It's always good to add things rather than start removing things from the schema that's not needed. That kind of concept helped with the velocity and the time frame because it was easier to implement in the templates based on the device role. We can talk about how we implemented the templates there. If you want to go on to the next question.
Yeah. So for this generator, this was definitely a larger generator, right? Because there's tons of objects to run. Um, we can't really build the overlay and underlay until we have the physical components. So this was our second step. And it's one large generator. So touching on what Alex just said with the velocity, one thing we learned was our generators were really big. So moving some of those into the template really helped here just due to the amount of objects that were being created. Um, the way we kind of determined a lot of like maybe BGP peers and stuff like that was based off either interface roles, device roles were another big thing, right? We used IBGP, so links didn't necessarily matter, but we understood what leaf and spines existed within the pod and how to connect those. Um, and with such a large deployment, there were a bunch of prefixes to assign to links, as well as two IP addresses on each side as well. So having resource managers for the point-to-point links helped a
Yeah.
lot
So, so we
with
could take
this.
like a a large range for like point-to-point links. We have a resource manager that hands out smaller prefixes. So we go and request the next available prefix of a /31, and then we could then that creates the prefix in the database in Infrahub, and then we can then go and say assign into IP address 1 and IP address 2 to the different side of the links, and we also save that in the database. So it's like all fully modeled using resource managers, quite good. Um, yeah, the resource managers were very helpful in that aspect.
Yes, and one thing, speaking of, people at OpsMill, what we ended up doing here too is we got so far down the path, and ultimately a lot of the day two workflows that they wanted ended up becoming, we're like, wait, it's kind of what we're doing day zero. So we ended up writing a bunch of code to kind of do some of the day two stuff within this as well. So kind of reusing those, right? We had a library, so we were able to just call Python functions and kind of use some of, I guess, the future stuff, but within this context. So it helped us deliver day two workflows a little bit more, but we kind of tried to keep that focused on, the scope of each of those day two workflows. We did separate these. Mainly, initially, what we were thinking was like, cabling and then the overlay. Due to the deliverables, cables had to be done first, but also some of the modularity. So if we needed to rerun the logical, we didn't have to rerun all of the physical cabling and all that. So that did still give us some of that separation and speed, that we didn't have to regenerate all of the cabling. Is there anything else you want to touch
What
on
would we do
this?
differently?
Yeah, we'll go into that for sure, but it's definitely smaller is a lot of what go big or go home is not always a good mantra to follow, I
Mm,
guess. So that is what we learned here.
perfect. So artifacts. Again, this was another key point of showing a customer a database with all the data in. Obviously, they were able to navigate and see all of it. For the automation team, that was fantastic. They knew what they were looking at. They could query the data. But for the network architects and people deploying the data center, they want to see output. What does this data in Infrahub have an impact on their day job? So we built a GraphQL query that queried for the device information and the relationships from Infrahub. We took some of that and we used a Python transform to do some kind of underlying filtering maybe and some processing under the hood in the transform. And then we used Ginger templates obviously to render the configuration. You can kind of see a structure of how we organized our Ginger templates. So there's like a master template, main.j2, you can kind of see at the top there on the right hand side. Um, but it meant that we can actually, in our templates, is we could pick a template based on the device vendor, essentially. If you changed the vendor or swapped it out with a different vendor, we would have then the mirror image of those templates, but for a different vendor. So you could easily swap it out, and you can see that some of them have a role, so there might be, for example, features and then role. So based on the role, whether it's a spine or a leaf, the Cisco devices had different features enabled. So we're able to separate templates into how they were used on a role basis, which was kind of good. We also used the kind, and we talked this about the three primary attributes: role. The other one was kind. So we have like a Ginger template for the SVI interface or the lag interface, so we can separate and make sure they're all independent and more easy to manage. And then we did have some shared stuff in there, but some key things we did was like include, obviously, is a cool one in Ginger to use. We're able to filter out VLANs by using select attribute. We used macros, which was really good. We used custom filters to convert ASN to integers or convert a VLAN list into like the comma separated or range values that Cisco accepts. So we did some quite cool stuff there. Most of you have seen this before. It's just templating. But it's one data model, but the output could be any vendor. And the role derives the configuration differences. I think one key thing here as well is that because we were able to say, okay, this week we're working on the interface parts of the templating. We were able to generate that so quickly once we had the information in Infrahub that the engineers were able to see the tangible output of the data in Infrahub, which was really good. And Infrahub is really developer friendly. So we had PyTest running against these. You could specify a query and what the output should look like. And if there's deviations, it would tell us that there's a deviation of like, hey, this won't work, and it will fail the test. It's really handy to have those developer friendly parts of the platform to help us generate configurations. The next slide just shows kind of what this looks like in Infrahub. You get an artifact that's attached to a device, and there's an example of what the configuration might look like on the right hand side. It's not the actual configuration, can't show that, but it's utilizing some of those key concepts.
Awesome. Yeah, so our final deliverable is the day two workflows. This really follows the same process, so hopefully we kind of capture that, right? Typically, we start at the schema by understanding what the requirements are, and then implementing these within a generator that then allows us to, or Infrahub to take care of the life cycle of this service. So those are very important building blocks. One of the differences around these day two workflows is the artifact. In the transforms, we didn't have to change those. Basically, they got to reuse it, right? Because one of the workflows was adding a rack, which ends up adding devices and all that. So we'll get new configs, we'll get a new cabling plan. So that was very powerful. And then we get the config. With some of the services, it ends up just being, updated diff is what they end up seeing whenever they run it and open a proposed change. So we got to reuse those for free, and mainly it was trying to figure out, what the requirements were, and then building the business logic in a generator for it.
Yeah, so for example, one of them was to add a VLAN to the out-of-band network. And the purpose of these kind of services is to make incremental changes after the initial fabric deployment. But as Mikhail said, we developed these in collaboration with the day zero kind of state of the project, so that the generators that built the fabric actually leveraged the generators for these kind of day two activities or services, if you will. So we had input parameters. We had to work with the customer of like, when you add a VLAN, what information do you need? What VRF it goes to? What prefix is required? all that good stuff. Are you adding it to all pods? Are you adding it across or to only a certain amount of pods? We had to work out this with the customer. So we had a few. We had VLANs, VRFs, extend pods, delete racks, add racks, things like that. But yeah, so the benefit of our approach using the library was that there was one implementation, but two invocation patterns. We could call it separately. And then the generators are kind of just thin wrappers around a larger kind of fabric library. If you want to move on a little bit, yeah.
Yeah, definitely. So when um, we're talking about the generator, there is some of the schema design. So when you build a generator, typically it'll have a schema tied to it to provide inputs and make sure they are have guardrails around it. So for this specific workflow around adding the VLAN through gather requirements, right? Initially, it was determined that the VLAN would be applied to all pods. That ended up not being true. So we ended up adding, pods being a mini relationship, and they get to kind of decide what pods it should be deployed to. There were use cases to maybe not have them everywhere. The VLAN must be tied to a VRF, so that was a mandatory relationship. But I think that's the great thing about these generators is you can have straight attributes, right, to define maybe toggles of and options for it. Um, but you also get to tie it to existing objects in the database, so you're kind of building with those parameters, and those are really useful. Another requirement is really assigning a prefix, so we ended up using a resource manager for that, and basically they select a pool that they want it to come from, and then the pool has the size of the subnet in it. So that was very useful for them. Um, with these are kind of done on top of it. So typically you'll follow the same workflow that we recommend with creating a branch. You add the service, which is basically just adding the schema object, the actual instance of it, opening the proposed change, and then it running within the pipeline. So it'll run the generator and then generate the new artifacts for it. But the generator ended up, deploying a bunch of different things. All the little objects it ended up creating was like SVIs, which actually included like HSRP as well, the VLAN. We add the VLAN to the L2 domain, which is, Alex touched on that earlier. It's kind of at the different building blocks, but we're able to kind of, go up and down the hierarchy and understand what VLANs to pull from for that.
What does the output of that
And
look
then
like?
the
Like,
output of the
yeah, of like
generator.
the once you've added it and the pipeline's run, what does the engineer see on the output?
Yeah, they'll end up seeing like the data changes. So what they'll be able to see is ultimately what the technical layer models is what we call them, but basically the implementation details. So they're able to see the data that's changed and then the artifacts, how those are affected with those changes. And then they get to kind of that helps them understand, okay, this worked the way it should. These are the little config changes I would expect from running this
Yeah.
service.
And the next slide shows that, I think. Perfect. Yeah, so it's a very
Yes.
simple example, but showing, editing the description, for example, will show editing the artifact output, which is what the customer's familiar with. So Christian had a question which we'll talk on next, which is how the deployment uh, went. So the
Sure.
customer used ZTP for the initial deployment and then are using other tools afterwards. So, for example, the first time they turned on the device, we used DHCP ZTP, which will pull a Python file from HTTP server. And then the Python file actually goes and queries Infrahub for the current up-to-date artifact for that device, and then it starts running. But an important part of the process is it will do the upgrade as well as part of that process. It will upgrade to the correct version and then pull the correct configuration. we were you can't believe how amazed we were that the first config that was pulled onto a device actually worked. It was quite a miracle, but there were some small teething issues, but less than you would think. And at that point, it was just template semantics of like there was a space there or misspelled something or and what have you, which we could have worked around, but we had reference configs from the start of what the config output should look like, which is what we used during the testing phase of building this. Because we just say there's a 50% like savings for deployment, but the customer actually stated earlier that it's kind of unquantifiable at the moment. There were many savings for deployment, and it saves engineers time for deploying config. So anything you want to add there, Mikhail? We can go straight onto the lessons learned.
Yeah, I think yeah, ultimately the whole process using Infrahub and all that was the great savings, right? And then they were able to um, really realize all of that. So all the features and everything we talked about kind of helped us reach this savings perspective. But yeah, let's move on to lessons learned. Um, I'll start with the first
Yeah,
one if you want. The decoupling the external constraints. Ultimately, what ended up happening was it was kind of complex with some of those physical things. I think you run into that with a lot. But having to generate the cabling plan, there's different ways we wanted to handle it. And with the deliverables, we had to kind of handle it in a very like sequential way. So what we kind of learned was like we need to actually decouple this from the physical. So let's generate, the logical components in the fabric portions, and then in a separate process, we'll end up actually coupling those back into the physical constraints. But that basically would allow us to do basically, can we generate the fabric in some sense? Yes, we can. We have some of the connections, and then at a later date, whenever maybe the data center team or whoever does the physical kind of layout of the data center, we can ingest that data and then map devices, fabric devices or OOP devices into the rack. But this should help a lot kind of moving forward. Um, the other one, I guess that kind of comes with that is the even smaller building blocks, as we kind of mentioned. We had two generators to do the physical and the logical. And with that, it was just a little bit hard because whenever we ran either the physical or logical, we couldn't break it down into like, can you only run it for a pod, right? We're trying to iterate away on the design for pod one or pod three or pod 100, whatever it is. So breaking those down even further into the building blocks is something that we would do moving forward. Do you want to talk about the
yeah.
last two?
So spend time on network design. I mean, any company can make efficiencies in their kind of network design and what to do when designing a fabric, but ensuring that it's designed with automation in mind. Um, we want to kind of treat it as cattle, not pets. We want to deploy this as fast as possible, especially these customers deploying these large data centers. It's money that they want to get this operational as fast as possible. And if they can cookie cutter as much as possible, it helps us as network automators. So yeah. And then the kind of next one is that kind of leading from the last slide is like the savings. The savings are kind of unquantifiable. So the next kind of leading thing on is how do we measure the impact of what Infrahub had? What was our speed to delivery quick? Were the data center team able to deploy faster because of the information? How many errors were they during the ZTP process? All this good stuff, which was really, really helpful.
Awesome. There's a question. How did the configs for the day two workflows get updated, and that was through the proposed change process. So the generators again are just a service layer typically. So the schema is, the inputs are very bare, but the generator ultimately ends up building all the underlying objects. So that's kind of what that does. So once all those objects exist in the database, it just reuses our artifacts that we've already created, right? Our configuration artifacts, even our cabling plan, because whenever new devices get added, the updated cabling plan got shipped to the DC team who then racked and stacked it. So that's kind of the synergy, I guess, for lack of a better word, among all these different features and stuff that we used.
Yes, and Tyler, compute was modeled. We did have a model for compute that was then like the GPU servers that were then again cabled to like the InfiniBand stack. Yeah, it was modeled, and yeah, in regards to the artifacts, Infrahub's smart enough that it tracks the query and will only regenerate the artifacts that have changed in the database. So it doesn't unnecessarily regenerate configuration. It will understand that there's a difference on the branch, and only when there's a difference it will regenerate the artifact. So we're coming up to the end, so we'll quickly move on and hopefully get some more. Oh, Christoph had another question. How was config pushed to the devices? Initially, ZTP process, and then going forward, they used Ansible as the deployment methods. I think it was Ansible.
Yeah, they had some existing stuff using Ansible, so easy to change. Some of these we've touched on.
Yeah. So when we started, object templates didn't exist. It didn't. It didn't exist. Going forward, we use object templates for as much as possible. It allows us to iterate a lot quicker. It also allows the architects to define their own templates rather than having to edit Python scripts. For example, they can define a template for a certain device type or a rack type, which is really good. One issue we had during the transforms is that we wanted some kind of functionality that network engineers are used to. So there's a common network utils package, and we add that to Infrahub so you have access to it. Do you want to go through the next two?
The scalability and performance.
Oh yes.
Alex,
Um,
sorry.
so
Sure.
uh, during the process, obviously, it's a lot of data. So a lot of we found a lot of scalability and performance issues, obviously, with Infra, which is good because everyone benefits. The community members benefit, which is great. So we were able to make improvements in how the backend queries for data, GraphQL performance, um, how artifacts are generated. Lots of scalability and performance improvements were just uh, gathered by doing this. Um, the conversion of object types, this was a good one. If you have an L2 interface, how do you convert that to an L3 interface as like a day two activity? So this was a big feature request that happened as well during that process. Do you want to cover the last two off?
Yeah, great. So I think one of the attendees asked this, but did we end up using the event triggers? The feature did not exist at that point, but it was, one of the key drivers of like, hey, maybe we should reconsider this. Um, so basically, the event triggers you set parameters around it, and you could trigger things. I think, what do we support today?
Generators,
Generators,
groups.
um, yeah, groups. So those kind of go into there, but that ends up taking it out of the proposed change so it could run, and they could kind of deal with that. Like once they add the actual service object, it'll trigger that. They could do other things, and then whenever they're actually ready, they could then open the proposed change, which will go through the pipeline, CI pipeline that we have in the product. So that was another one of the big features that came out. Another need that we figured out was the relationships and profiles. They currently only supported attributes, but through the process, such as like interfaces and stuff, it would be good to add, maybe the L2 VLANs untagged and tagged VLANs to it. So that was another enhancement that came out of this project.
Um, and we just want to give a
Oh,
shout out. This is the OpsMill team as of June this year, June, July this year. And every one of them had some form of impact on this project, from the back end engineers to marketing to everyone else. They really smashed it, and they did well. So, any other questions? So, we got one about the ZTP process. Um, I we didn't build the ZTP flow, so I'm not too sure if they uh, did the status from provisioning to active during the process, but that might be one that they will be looking into to kind of track like the successfulness of a deployment going forward, which is really good. Um, so we will be using things like that in future to track the deployment of devices.
yeah, and some of that is good visibility for management there, right? Where is the DC build process at? So that's kind of how we're using this, Infrahub and those
Yeah,
statuses. Did we miss any, or is
I
there any
don't think so. I think
others?
we've got. I think we've tackled as many.
Yeah, I guess we'd like to appreciate, or thank you for joining us and all the questions that were asked. If you want to dig deeper, join our Discord and we could kind of dive deeper. We're typically pretty open to, jumping on calls and stuff if it's something that requires more discussion. But it's always good to ask questions in front of people, right? There's probably someone who wants to ask the same question. So we're more than happy to engage
Yeah,
with y'all in the
Damien
Discord.
put a good point in chat there, is that we have a project coming up that packages a lot of what was covered today in a generic way. We call it a bundle because our package is like a bundle. So it'll cover some of those generators in a small way that are chained together, some of the artifacts and everything. So yeah, feel free to reach out and get in contact.